So we have the first one is there's improper, improper, proper. And let me show you why, because I know you're dying to know. It has to do with if it goes to infinity, right there, and infinite, it's the whole thing with the asymptote and trying to get an area underneath where there's an asymptote involved. So going to infinity makes it improper. One of the endpoints at infinity, improper. A vertical asymptote that's inside the interval of integration. You have a vertical asymptote. So here's 1 over x minus 2 squared is this the 2 up pieces, and it's shifted to the right 2. Well, at x equals 2, there's a vertical asymptote. And so in there, I'm getting an area underneath the curve, and because there's 2 vertical asymptotes, that makes it improper. We'd have to do a 2-part limit, 1 to 2, 2 to 5. C is vertical asymptote at an endpoint. That's a bad thing too. It's kind of like infinity. You have an infinite area because you're going up against x equals 2. D on the end, that one's okay. That's a proper one. There's no infinite region within the area of integration, so you're good to go.
I'm grading this,
Right now, no. Oh, am I grading it? Yes. And no, I'm just going through it just for your own, just for interest's sake, because I know it's fresh on your mind. And to be honest, I just want you to, as much as you can learn from this, the best. And I like going over it really soon, because if I don't, I totally forget. So, yeah, you could. Oh, I want it today, but I know you won't write anything down. I'm trusting you. So on this, answer the following. These here, all it has to do is this thing converges when a is greater than 0 and p is greater than 1. And it converges by happenstance. We proved it once in class, and anytime we can do it again. It's just taking the integral of this function right here. If you do that with those endpoints, it'll converge to a to the 1 over 1 minus p over p minus 1. That's a shortcut. You don't have to do that. But if you have a function that converges, then it will converge to that value. So, and then down here, the general rules for number 3, this is it right here. In general, it'll converge when p is greater than 1 and a is greater than 0. If a function diverges and you have one above it, the function above it will also diverge. If you have a function that converges and one below it, then the one below it will also converge. That's the generalization in number 2. And if I keep going, so that's, I put in a little shortcut. A converges to something less than or equal to k. B is a maybe, because if you have an under function that diverges, if you have an under function, or an over function, here it is, over function that diverges, and you put one underneath it, you don't know for sure whether it converges. So the top one definitely diverges, has an infinite area. If you put one underneath, you're not really sure. It's a maybe. It could converge, maybe it does, maybe it doesn't. We need more information. So, yeah, there you go. Converge, maybe, diverge, maybe. Okay. So you can just kind of see how you did against your thing, but don't change anything. 4, hey, remember, we're trying to compare it. If you can find a function, 1 over x to the p of some kind that you can compare this to, on an indefinite integral, do it. Or an improper integral. Try it. So I compare these two. I got crisscross applesauce. If you do the cross multiples, you see that the left function is less than the right function. 1 over x is underneath the other function, and 1 over x diverges. So a function that's over a divergent function, I put a little graph here for you. So I got 1 over x that diverges, for sure, because 1 over x has a p that is not greater than 1, so that's why it diverges. Then any function you put over top of it also diverges. So the green function is the other one on top of it. So when a function's greater than another, it literally means on top of it. That helps in another problem later, too. Here's the other comparisons. I'm just going to run through them real fast so you can just compare it to kind of get an idea of what you did. So I got convergence for 1 over x to the 5th, which is how I'm comparing this one. This, in general, b is like 1 over x to the 5th if you look at just the leading coefficient or leading term. And if you compare this function and you do cross multiplication, you can see that our given function is less than a known converging function, and if it's less than a known converging function, underneath a convergent function, then your under function will also converge. So then, it converges too. So B is a converge. So what do we got? Diverge A, converge B, and then we want to compare these in C. We got to converge. Also, because we know 1 over x to the 5th converges, and we found out a function is underneath it, so it also converges. And then, oh my, this one's a little wild. If you didn't come up with this one, not the end of the world. I don't know if I gave you some hints, but the idea is sine of x, the absolute value of which is under 1. So the biggest it could have been is 4 over x, and the smallest it can be is 2 over x. So it's somewhere in between there. And so if you make that comparison, well, if you look at 2 over x, it's like 2 times 1 over x. And when there is an a that's greater than 0, which we've got, but a p, which this is 1 over x to the 1, if p is not greater than 1, then this thing diverges. 2 over x diverges, 4 over x diverges, so our function diverges also. Both are divergent. That's a good one. Okay. Keep on rolling. Now, take a look at this one. Antiderivative. That's a u sub, just in case you're wondering. Nothing fancy here, I'll just let it upper bound. If I put the limit to infinity of that first, if you do the antiderivative here, it's 1 over e to the x cubed. So, or 1 over 3, so you have a denominator with e to the x cubed, and when you go to infinity, that's 0. That's all that is. And then, if you put in the upper bound with 0, it's 1, so negative 1/3 times negative 1, a positive 1/3 result. Okay, and then this little dude, it works. 6 would converge because it's a greater than 1, or a greater than 0, I'm sorry, and a p greater than 1. Even though it's 1.01, it'll work. So do the antiderivative. I was kind of shortcutting on this one. I put in infinity without using limit notation, which is a little naughty, but I was running out of time. So I just said, hey, we're dividing by infinity, so that would go to 0 if we put the upper bound in. And then if you put the lower bound in of 1, then you're dealing with 1 to the 0.01, which is 1. So we just get minus a negative 100 or positive 100. Okay, you're welcome to go back and look at this. I'll upload it for you. So there's antiderivative for this one. Now, this function is not an improper integral, it's just 0 to 1. So you guys can totally do this. It's just a regular old integral. So, yeah, I think we can get by without the limit. We're just putting in 0, 2 minus 0. So, nothing fancy. See the log? Can't put in, what is it? We're having troubles there. If you put in 1, that's okay. 1's good. It's putting in 0 that's an issue, so can't get to those. So we have to do a little bit of a limit. This, if you want to think of, I liked the graph of this one just to get my mind wrapped around it. That's log of x shifted to the right one. And so I put some key values in there just to give you an idea. So if we're going to do the area from 0 to 1 on this thing, so there's some funny business going on there from 0 to 1. What do you think about that?
Diverges. You can never take ln 0.
There isn't, so that butting up against there. So, hang tight. Check this out. If we just go ahead and take a peek at upper bound 1, can't really put in that, you end up with an infinite value, because it does go to infinity down below. Doesn't matter, any infinity is that. That's what divergent means, the area is infinite. We can't actually confirm how much it is. Arctangent, if you take the integral of 1 over x squared plus 1, that's arctangent. Just get that one stuck in there. And arctangent to infinity, we talked about that yesterday. Upper bound, arctangent to infinity is pi over 2. Arctangent of 0. Remember, it's a sideways tangent graph, reflected over the y equals x line. So if you put in 0, you get out 0. And next one, antiderivative by parts. So this is an issue. It's just a 2-part graph. It's a piecemeal graph, piecewise. So I broke it up into 0 to 1, 1 to 2. Antiderivatives are each No issues with substituting those in directly, so you just plug them in and rock and roll. 3.5. And I think that's the end of that section. Last, 11 is a good u substitution. Just make sure it's x squared minus 2 so you can get the full substitution. And if you do that, it's u to the negative 1/3. So antiderivative with u back in there. And then this one, infinity, I think I used the right notation this time. Did I? Nah, I just did it by. If you put infinity in here for the upper bound, you get infinity because it's just a regular, kind of like a cubic function with some extra oomph. So it's going, as you put in values larger and larger, the function gets larger and larger, it'll go to infinity. If you put in 2, you get out 2, 3/2 times 2 to the 2/3, which is just dumb because infinity minus something is still infinity. What do you think?
A second. I don't know if I even did.
You guys getting super sleepy? Good, I have something to help with that in a minute. So, dance party, that's a good idea.
Okay, good, I did it.
12, the free response. We talked about that one yesterday, we set it up, you guys were to do it at home.
Look at, just my paper looks like it's been annihilated.
You did annihilate that, you like to squish your stuff in.
Like,
So,
not I erased it,
let me get the limit stuff for you.
It's unreal.
You go do a free response. All right, the u substitution will take care of this antiderivative. So this is just the antiderivative. If I just focus here, if u is negative x squared, you can simplify it to just the integral of e to the u.
Wait, is it bad
With
if
a
I
negative 1/2.
tried to do integration by parts on this?
On this one,
3 times, yeah, and it didn't work. No, I know it didn't work. Like the UDV thing.
that sounds like that
I
would be
mean, no,
painful.
I did U substitution finally last night, but
Seems like it should still work. I mean, it seems like you could do it.
you get negative pi though, is the problem.
Must be something in there because it's okay. It ends up being positive pi. Well, that'd be fun to look
I know,
at.
the
It should
answer-
work.
The
There's no
answer is
reason it
positive
shouldn't.
pi when I do it with U sub, but I tried it the other way and it gave me negative.
I wonder what it is. It should be this. You should be able to do both.
If u is in there, then there aren't 2 functions, because one of the functions is.
I'm just gonna like tape to my head.
Yeah, I wonder what
What
the.
is that? Oh, I need
Huh. That'd be interesting to look at. So,
doctor's orders.
last piece there, antiderivative is once you do the u substitution, it's a direct. You can everything's almost direct substitution, but I'm running the limit there just so you can see. I did it separately with the upper bound and the lower bound, and I did the upper bound got me 0 because I got e to the x squared in the denominator. Then I put in 0 over there, and it gave me just e to the 0 is 1, so I got negative 1/2. So all the things are good. Hope that was all good. Pi was the deal. So we did the area of the other one. I just put a note to myself. I was going to maybe do this on the board if we had some time in class because I left all the work up there. So it's not going to be on this little note sheet because I ran out of room and I thought maybe I was right on the board. We'll see. Let's see if we have time. And then let's go to 14. I said you guys could do this for extra credit. So here's 14. Just take this is the quotient rule. So you guys remember if you're going to get g prime, because that's what you do when you want a maximum. So part A says find a maximum, your brain goes set the first derivative equal to 0. So you take low, how do you guys do quotient rule?
Low D high minus high D low all over low squared.
Yeah, low D high less high D low and square of low we go. You can do all kinds of fun things. Lots of songs out there in this world for that stuff. Good. Low D high less high D low over the square of low we go. Got it. Simplify.
Low may every time I hear it, like, cause the day we learned that rule, I went to ch9 had low may, so I don't know why.
That's funny.
It's so, it was so good too, that's why I remember it.
That's interesting. A little simplifying, I uploaded this so you guys can see it.
Low, softer.
Don't forget when you're doing
So,
derivatives equal to 0,
Chow is hard.
don't forget you gotta only have to focus on numerators. So
soft, really thick.
don't
Yeah.
spend any time worrying about the denominator, which is always positive in this case. So look for cool stuff. If you guys have an option to, you ready? Call it. If you have a denominator that's always positive, look for fun things like, hey, that's always going to be positive. I can ignore that because this is all adding, squaring, stuff like that. This up here, if I want to know where the derivative is equal to 0, you can focus on simple parts. Like, only have to find out where this factor is equal to 0. Save yourself the time of trying to solve something more complicated. Numerator's usually enough, unless there's something
The
funky.
answer is 1. I think that's
So it's
positive.
1/2. And then what you did is you tested around it to make sure it's a max. You want to make sure it's there. So in a free response, you want to have this test. You want to make sure you do your test to be sure it's a maximum. So you want to put in your values around 1/2. I picked a 4th and 1.
Well, why wouldn't you just pick 0 and 1?
That's a good question. What do you get when you put in 0?
Do you really?
No.
Put in 0. No, you get a positive. It's the
Yeah.
same. The interval, well, this is why I didn't put in 0. It says x greater than 0 is our domain. Though, knowing the look of the function, it's fine.
But for this purpose, we couldn't use 0 as a smaller value.
I would only say that I think you should stick with the domain that's
1/4
given.
and 1.
Yeah. So
Okay.
if you have a domain that goes with it, I don't know if you'd lose any points for that, because it's the way it looks, and I think it's a no graph, no calculator section. So I'd stick with your domain. So 1/4 works nicely. 1/4 squared is 1/16. 1/4 of a 16. 1 minus some fraction is still positive, so no big deal. The numbers aren't bad. Now, I got a max because it's positive and negative around the critical value, and it turns out forever there's a downward slope. So that means to me that when I got to the max, I mean it's never going to get any higher than that. It's just dropping. So that's definitely the maximum. And you're supposed to decide if there's a minimum. If it exists, this is a funny one. Your minimum doesn't really exist if you're going to have an improper integral. So watch this carefully. There is no absolute minimum if you never actually get to the bottom. So x is greater than 0, so you could approach 0 and get infinitely close to 0 and never figure out where the bottom is. The other side of the function is you go to infinity and figure out where it lands. So there's no real minimum because of this asymptote stuff. Here's what I wrote up. If you get an asymptote, it won't bottom out. So you're not going to get an absolute minimum is what I wanted to throw at you. Okay. Finally, the last one. Hey, it says find the area of the bounded region. So x equals 1, 2, so it says from 1 on to infinity, and this is not arbitrary. Which function is the upper function? Let's say you couldn't graph it. Just saying. Let's say somebody says, if I held a calculator to your head and didn't let you touch it, could you figure this out? It's kind of like putting, like a gun to your head, but I'm in a
Yeah.
calculator, but you can't touch it because no calculator.
I sure.
You get it?
Yes.
Got it. Good. So look at those dudes. You could do the crisscross. Tell me which one's bigger. 1 over x is bigger than 4x over 1 plus 4x squared. You can do that. You can always compare two functions. Kind of fun.
Mhm.
I give it a shot. So the top function is 1 over x. It's barely bigger. Did you know that? Just barely. Just a wee bit bigger. Off you go. So now you can do it. I want to use limit notation to be proper about it. So limit it as b goes to infinity. Check this out. This is proper notation. To not put infinity in the bound, but to put a b or some dummy variable as a placeholder. So the first is natural log, so we're good with that one. The second one is u substitution because I can see that there's the derivative of this would be 8x, and I know this is a multiple of 8x. I'm good with u substitution, so I work that out. Little subby sub. And I got u to the negative 1. And so I know that's 1 over u, and that's the log of u. So 1/2 natural log of u. Put u in, not me. And you come in and you do the limit to infinity, but you don't put infinity as the upper bound. You put b, because it's cool. I needed some room, so I did. Awesome. So lower bound, awesome. You can put in 1 and get 1 over the square root of 5, no problem. Upper bound, this is where you have some fun. So you guys ready for this indefinite integral business? Are you ready for the first one? It's a doozy. Got the last one. That one converges. The second one, let's rock it. Okay. The issue is that piece inside the log, as the limit goes into infinity, what the heck happens to this as we go to infinity? and you guys know this stuff, so you got to do your, I factored out a 1/2, and so it was, because you can do that. If you have an x, you can divide out a 1/2 power. Leaves x squared. Remember, you just have to be able to put it back. So if I put half of x squared, it's still x. Square root of that. So I factored out a 1/2 power. If I go to infinity now, these have the same they have the same leading coefficient. I'm sorry, same degree in the leading coefficient. So you can do the ratio 1 to 4, and that's where the 1/4 comes from, because we're doing a limit to infinity. And then square root that, you got 1/2. So I can take that 1/2 now and put it in, because that's what the limit to infinity of the inner stuff is. Isn't that cool? Remember we had log of x minus the log of square root of 1 plus 4x squared? So there you have it. It's the log of square root of 5 over 2. And you can do other simplifying with that if you want. It's up to you. Done. Let me stop that.